Lesson 19 for Unit 1, Evidence, Angles, and Proofs. So learning goal is let's make convincing explanations. So in our warm-up for 19.9 Math Talk, supplementary angles. What are supplementary angles? Do you remember? Let's draw back our memories from 8th grade or even 7th grade, depending on what you were doing. And what does supplementary mean? We have EB or BE, which is a line. And then we have this angle carved out of it, angle DAB, all right? And if you just dabbed right now, good for you. Now we know a straight line has what degree, what angle measurement? 180, correct? Well, does that have something to do with supplementary? So supplementary angles are two angles that basically sum up to 180 degrees. So if we were to find the other angle, angle DAE, right here on the other side, what's 180 minus the 50 that's already given? 130. So that would be 130 right there. Okay. Angle BAE, the line itself, is 180. All right, figure B. If IG and line FH or HF are lines, well, we know lines have 180 degree measures, but for line IG, we already have this angle of 30 degrees. So what is angle IEF right up here? Well, what's 180 minus 30? All right, and then try to find the other two angles, angle IEH and angle GEH. Okay, and also what do you notice about the opposing or opposite angles? What's their relationship to one another? Same thing with C, it's just like figure A. So you have 65 degrees given. What is angle ECF? Okay. And again, you're using the idea of supplementary angles to find all these missing pieces. Figure D is very much like figure B, right? Where you have these two lines intersecting one another. We have 135 degrees. BE is a straight line. CD is a straight line. So what would be angle BAC, especially if you already have this 135 degrees over here? All right, and then find the other angles, angle DAB and angle DAE. All right, and again, what do you notice about the opposite angles? All right, 19.2, that can't be right, can it? So Diego makes a conjecture about a ray which meets this line L. Okay, so the ray's flying over here and it's hitting line L. Okay, the dashed rays are angle bisectors. What does that mean? It means these dashed lines cut this angle or their perspective angles perfectly in half. Remember, angle bisector, bisector means two, so it cuts the angle in half into two pieces. Now, he makes a conjecture, Diego, and he ends up saying that the angles formed between the angle bisectors is always a right angle no matter what angle between R and L is. And they flat out say it is difficult to tell specifically which angles Diego is talking about in his conjecture. Yeah, I have very little idea of what this kid's talking about. Now, I'm looking at it and I see the right angle right there. Is that what he's talking about? So that's what's got me confused. Like, that looks like 90 degrees, right? But how can we be sure? Now, we know that this angle here has to be the same angle here because of angle bisector. We know that for sure. We know that this angle here has got to be the same measure as this angle right here because, again, the concept of angle bisectors. Let's call them names. Let's say this is angle A. And this is also angle A because they're the same measure. And these are angle B's. Okay. Now, maybe if Diego is saying A plus B is always going to be 90 degrees, right? Which kind of validates why it looks like a proper L, right? And we do know that the straight line, line L, has 180 degrees. Well, if A plus B has to be 90 degrees, then would you agree that 2a plus the 2b's will be 180? So let's see, is the conjecture true? Explain your reasoning. It is if, right, a plus b is 90 degrees, then 2 of those a's plus 2 of those b's, right, those angles, would give you 180 degrees. Right, so it's just he's got to be very detailed on what he's talking about in terms of the angles. There's so many. Okay, so this would work with the idea the line L is adding up to 180 degrees. And then because of these angle bisectors, you have like these two different angles. All right. So yeah, that's basically the explanation there. So he's correct. It's just he could have probably worded it a little bit better. All right, 19.3, convince me. Here are two intersecting lines that create two pairs of vertical angles. What is the relationship between the vertical angles? Write down a conjecture. All right, label the diagram that makes it easiest to write your conjecture precisely. All right, so the vertical angles, what does that mean? So let's draw. We know that this angle here, right, plus this angle here, so let's say angle A, and we don't know for a fact if they're the same measure, and angle B have to add up to 180, right? What do you think? What do you think the relationship is between A and the bottom angle right here? Okay, what do you think the relationship is here to B, to angle B? Okay, we know that A plus B is 180. Well, we know these two angles have to be 180, right? So I don't know if you've already learned about vertical angles, but vertical angles, angles that are across from one another, all right, when you have this two intersecting lines, all right, vertical angles means that they're congruent to one another, all right, they have the same angle measurement. So angle B right here is going to have the same measure as that. So those are vertical angles, okay? And angle A, right, is going to be a vertical angle to this angle. Okay, that's what it means to be vertical angles. Now my conjecture is, let's see, A plus B has to be 180 degrees, right? As do the other two angles. So if you take 2A plus 2B's, you're actually going to get a full 360. Okay. So in summary, for evidence, angles, and proofs, in many situations, it's important to understand the reasons why an idea is true. Here are some questions to ask while trying to convince ourselves and others that a statement is true. How do we know this is true? So how do we know vertical angles right here are the same measure? All right. Would these reasons convince someone who didn't think it was true? Is this always true? Right? Is these vertical angles always going to be congruent? Always? All right. Or only in certain cases? Can we find any situation where this is false? So in this lesson, we reason that pairs of vertical angles are always congruent to each other. So angle X here is always going to be the same degree or measure as angle W here. Okay, angle Z and angle Y are going to be also the same measure, no matter where AB and CD, no matter how they intersect one another. Okay, and that's again going with this idea that these two angles have to add up to 180 degrees. All right, that is it. Have a beautiful day.